Welcome to my channel, and in this video I'll be explaining the line integral aspect of your Math 201. And along the way I'll be telling you some things you have to keep in mind for your upcoming examination as well. So if you're a type that you've been struggling with this topic, or you're even scared of your exam because of this topic, watch to the very end. By the end of the video you should gain enough confidence to tackle this kind of question in your exam. So let's start. Now for line integral, it's of two types. We have the scalar line integral and then we have the vector line integral. So in this video, I'll be dealing with the scalar line integral, and hopefully in the next video, I'll be talking about the vector line integral. Now the general form for these questions is you'll be given this integral to evaluate, and it will be a function of x and y dx and then plus another function dy. So basically the way you want to solve this question is that you want to make the two of them to be dx. Like you want to find a way to change this the y to dx, so that everything will be dx, and then you can integrate it normally like you integrate other integral. Or it might be in this way as well. Now if it is in this way, and if you are given your c to be in parametric form, whereby x is a function of t and y is also a function of that same t, it might not be t, it might be another variable. But if that it is now parameterized, right? X and y are given as a function of the same variable. It might be x of p, for instance, and then function of p, both of them. So once they are in the same function, so it's not easy now. So you just want to change those dx, dy, you want to change them to dt in function like the variable you are given. So if it is p you are given for both of them, you will change this dx and dy to what? You will change it to dp. I hope you understand. So in that case now, everything is now in the same variable dp. So and that is our aim. That is what we want to first do before we start integrating this line integral. Now if you are given, how would you do it? It's basically simple. So in case you are given in that parametric form, then the integral becomes this. Now don't be scared, it's still like what we have here. So it's like p as a function of x and y dx, right? So you now change, of course x is now what? X is now this. So this is your x, this is your y, like we had it before. X, y. Now how did they get this? You can see that the dx has now changed to what? All this. Well, it's very simple. So from this x equal phi of t, so if you add d dt and d dt to both sides, and then you want to get your dx, if you cross multiply or you multiply both sides by dt, what would you have? You have dx to be, so dt will cancel dt, so your dx becomes d dt of this multiplied by dt, and then this is what this can be expressed as phi prime of t. So you are still saying the same thing, just like if you want to say dy dx, you can just say what? Y prime. I hope you understand. That's when y is a function of x, maybe like y is equal to x squared or something. So basically that's what they just did here. So of course now change the dx to what? To this dt. So and this is what? This is phi of t and phi prime of t, and the same thing they did here. Okay, y was what? Y was phi of t. So if you add d dt, so to both sides, I hope I'm getting it. Yeah. So and you want to cancel dt from here, so you multiply both sides by dt like I did for x. So you have dy equal d dt of phi, then multiply by dt, and of course this also, as you have it here, is like phi prime of t times dt. So that's your dy. So that's why they changed dy to everything here. So it's very simple. Now that's just what you want to first do, and then you can now integrate. So let's start taking a look at some questions. So you are given this integral, right? You have to evaluate this line integral here. Okay, and from point A to point B. So like I told you, what you want to do is to change dy to dx, and also y to x. So everything should just be in the same variable. You turn everything to a single variable. That is the one thing you just want to achieve first. So how do you solve this kind of question? It's not easy, because you've been given y as a function of x, so you can now replace y with all these side in your question. So your integral will now change to what? So the integral will be, now first let's get, you want to change dy also to dx, right? So let's get dy in form of dx, and that will be dy dx. Here will be what? Will just be 1. Is that not? So this one will turn to 0 and this one will turn to 1. So from here you notice that dy equal dx, right? Cross multiply, you multiply both sides by dx. Now you cannot go back to your integral, then I becomes the integral of x squared, okay, plus, now your y is what? Your y is going to be 2x. So that will be plus 2 plus x, right? Dx plus x minus y is what? 2 plus x, right? Squared. Then you can change your dy now to what? To dx, because dy is now what? Is now dx. And then you integrate. It's so simple, right? I don't know if I should integrate it to the very end. I believe you can do that. Anyway, I will be integral of x squared plus x plus 2 dx plus, so if you find x plus 2 or 2 plus x, sorry, 2 plus x, 2 plus x squared, that will be 2 plus x multiplied by 2 plus x, that will be 4 plus 2x plus 2x plus x squared. So that will be x squared plus 4x plus 4. So plus, don't forget we have x already, minus, so when you evaluate this is what you get. So you get x squared plus 4x plus 4, or in brackets dx. And then I is equal integral of x squared plus x plus 2 dx plus, so here we have 4x and x, that's 5x. So we have sorry, now notice I made a mistake here. It is minus of, it's like, excuse me please, it is like this, minus of this. So it should be minus of whatever we get for that bracket. I hope you understand. So please don't do this mistake, because so you then get what? You then get minus x squared minus 4x minus 4, right? Now dx. I hope that's clear. So then you can now see x minus 4x as minus 3x. So you now have x squared plus x plus 2 dx plus, so we have minus x squared minus 3x minus 4, then dx. Then I equal, so the next thing is to, well, you might just factorize the negative out, or you just combine the two now, this and this. So dx, right? So you can just put the dx out as a factor. Then you now have what? You now have this cancels this, right? If you combine the two of them, it should be like x squared plus x plus 2 minus x squared minus 3x minus 4, all dx, right? So this can cancel this, okay, and x minus 3x will give minus 2x, 2 minus 4 will give minus 2, right? Dx. So that's your I. Then you can integrate. Now I'm making a mistake. It's in the form of dx, right? So if you check your points, so from point A to point B, so it's x comma y, right? X comma y. So in your integral, since it's in the form of dx, so change the x here will be what? From x1 from point A to point B. So x1 is your 0 and x2 is your 3. So your integral will be from 0 to 3. You have to add that to all this integral I've been writing. So and then till this very end, where we are having what? Integral from 0 to 3 of this. So and of course you can integrate now. So to integrate, you can do it in two ways. For here you can say integral from 0 to 3 minus, you can factorize minus, and then you just have this, okay, dx. So minus integral of 2x plus 2 dx, and that will be what? So that will be minus, so the integral of 2x will be giving you what? X squared, because it should be 2x, it's already raised to power 1, right? So you just add 1, and then divide by 1 plus 1. So that will be 2x squared over 2. So 2 cancels 2. So you have just x squared. Then plus integral of 2 give us 2x. How? Because 2 is like 2 times 1, right? And that would be like 2 times x to the power of 0. X to the power of 0 will give you 1. So you can say 2 times x to the power of 0 plus 1 over 0 plus 1. That will give 2x over 1. So which is 2x. Okay. And yeah, from 0 to 3. So your answer will be, if you evaluate that, that will give you. So how do you evaluate? So it should be minus x squared. So x squared, you first put 3, the upper limit. So that will be 3 squared plus 2 times 3, that's 1, minus, don't forget, you put it in this, you put the lower limit in that whole expression again. So that will be minus 0 squared. Everything will be 0 basically, right? 0 squared plus 2 times 0, so that will be 0. So everything will be 0. So the answer will just be minus 9 plus 6, and that will be minus 15. So that's your answer for this line integral question here. Okay. So if you notice any error, you can comment down below in the comment section. But I don't think I've made any mistake. Alright, so another thing you have to keep in mind for your exam is the properties of line integrals. Right? So what are the properties of line integrals? Property 1 I'll be talking about is the linearity. So it's the linearity. So what they are trying to say is that, so you can split your line integral into 2. You know, it is p dx plus q dy. You can change it to integral of p dx plus integral of p dq. Easy peasy, very straightforward. So that's linearity. Okay, in your notes you see it this way. So this is how it is in your notes, and yeah, it's still the same actually, because so it's like we're having this plus this and then you split it, meaning that you can split the integral into pieces. So then property 2 is the reversing direction. It's like you want to go from the Senate building to the cafeteria, and then you go from cafeteria to the Senate building. You don't have to go back and say you want to like take that journey again. Just add negative. You know, it's still the same. It's between that same point. You are still walking from, between those 2 points. So if you go in the direction you don't like, you don't have to like start again. Just add negative to the answer you get. You add negative to the answer you get, and then that gives you your desired answer. So if you go from B to A instead of A to B, you don't have to stress yourself. If you find the integral from B to A, then that will be equal to minus the integral from A to B. That's all. Just like what you have in your notes. So this is what you have in your notes. So if you go from A1, B1 to A to B2, that same integral, that same function, okay, it is minus going from A to B2 to A1, B1. You know, it's like you've reversed these 2 points now. So just add negative. That's all. So that's a property, meaning that working backward flips the sign. That's all. Then the third property is the breaking the path. So if the path is made of 2 parts, you can break it. Like, let's say this integral is C, integral of this first part. Then if you can break it to 2 parts, then it is possible. And then if you add them, you get your original part. So just like it is in your notes, if you have integral from A1, B1 to A to B2 of this function, that will be equal to integral from, this is the beginning, right? This is the end. Beginning, end. So you can begin here and then go to a particular point. That's not the end. Then you continue from that point, then go to the final end. So if you do these 2 integral and you add them, you get it as if you are going from the beginning to the end. Notice that you start from the beginning and you eventually end at the end. So that's possible. So I mean, you are going from A1, B1 to A to B2. So you can first go to A1, B1 to AM, BM. Then you go from AM, BM to A to B2. So you get your answer. So meaning that you can solve piece by piece and then you add. So those are the properties of line integral you should keep in mind for your exam. Now let's look at another question where we see this play out. So let's say you are given this integral. So this is like the second form that I gave you up there. So it's still like dx, dy, and of course you know what to do. So we still have to like get this dy in form of dx. and then your y, you change it to the x. Your y here to you change to x. So simple. Now, what do you have to do? So if you look at your question very well, you will see that I want you to get this. So from your question, you will notice something that you are going from 0 to 1, right? So this is your beginning, this is your end. End, start. So of course, x comma y, s comma y. So your x here is going from 0 to 1, and your y is also going to what? From 0 to 1. I mean from 1 to 2. So the difference is what? Is 1. And also, if you notice the relationship between your x and y, you see that for every value of x, if you add 1 to it, you get your y. Is that not? Y here is 2, x is 1. So 1 plus 1 is 2. Y here is 1, x is 0. So 0 plus 1 is what? Is 1. So that means your y is equal what? Y equal x plus 1. Now the question asks you to find it in a straightforward manner. That you should find it from that point you start from 0, 1 to 1, 2, like we have it in the question. Okay, remember, if you look closely for the second question here, it is asking you to go from the start 0, 1 to a point 1, 1, which is not the end. Then you now go from that point again to the end now. So you have to do two integrals here. You have to do two integrals here. Okay, so then we are given another one, which is the parabola. We are going to come to that as well. So now you have to establish the relationship between x and y. That's what I'm just trying to tell you. Because you have to change this y to what? To x eventually. So that's why you have to look at the point and you determine the relationship between them in case you are not given. I hope you understand. So we are not given the relationship, and we can see it from here that y is 1 bigger than x. So that is our relationship. So then, of course, from here, you can see that the y dx equal 1. So if dy dx equal 1, that means that dy equal dx, right? If you find dy dx, it's going to be equal 1. So, and then from there, you can continue your integration. So then your integration would then be from, now because we are expressing everything in form of dx, we have to change the dy to dx, we have to change the y to x, then the integral will just be from only x. You have to consider only x. So it will be from 0 to 1. Only x, not y value. So only x is changing here. So then it will be 0 to 1 of x squared minus y dx. I want to repeat the question. Plus y squared plus x dy. Right? So now we have to be changing them. So I equal integral from 0 to 1 x squared minus. Now y is already x plus 1, so we have to replace y with x plus 1, then dx, then plus. Now y is x plus 1, so replace y with x plus 1 squared plus x dx, because now dy is equal dx, so and we want all of them to be in form of x, so we replace dy with dx. Now we have I equal integral from 0 to 1 x squared minus x plus 1, sorry, minus x minus 1, okay, because you use the minus to open these brackets, and then you have dx, then plus. Now if you evaluate this, you have x plus 1 times x plus 1, and that will give you x squared plus 2x plus 1 plus x. Now the remaining x here, so that's the plus x dx. And then you have I equal integral from 0 to 1. So you can combine these two together, right? So this should be x squared plus 3x, because 2x plus x, then plus 1 dx. So since we have dx here and we have dx here as well, so we can have just integral from 0 to 1, pull out the dx, and then you have x squared minus x minus 1. Okay, then you combine it with this x squared plus 3x plus 1. So all dx. So from here you can see that we have I equal from 0 to 1 x squared, sorry, 2x squared, because x squared plus x squared will give you 2x squared. And then minus x plus 3x, that gives 2x. And minus 1 will cancel 1. So we have that dx. Then we can now find the integral of this. So that will be integral of 2x squared dx. That will be 2x cubed divided by 3, plus integral of 2x will give 2x squared divided by 2. I hope you understand that. That's like 2x squared. Then you add 1 and then over 2 plus 1. So that's 2x cube divided by 3. And if you do the same for 2x, it's already raised to power 1. So if you do plus 1 over 1 plus 1, so that will be 2, 2, like we have it here. So, and of course, that's from 0 to 1. So 2 can actually cancel 2. Okay, 2 can cancel 2. So if 2 cancels 2, so what are we going to have? We're going to have 2x cubed divided by 3 plus x squared from 0 to 1. Okay, from 0 to 1. So let's complete that. Let's complete that. So from here we can have 2. Now you can put the upper limit, which is 1. That will be 1 to the power of 3 divided by 3 plus 1 squared. Now minus the lower limit. When you put 0 for x divided by 3 plus 0 squared. So everything here will be 0, right? So we are left with 2 over 3 plus 1. So what will this give you? That will give you, it will be 2 over 3 plus 1 is 3 divided by 3. So if you find the LCM, you have 2 plus 3, and that's 5 divided by 3. So that's the answer for the first question. And of course, that is just for the straight line from 0, 1 to 1, 2. Now for the second question, they asked us to evaluate it, okay, along straight line from 0, 1 to 1, 1. So we have to do that. And from 1, 1 to 1, 2. So we have to do that next. So that is what we have to do now. So let me take this off. Also, our dy dx is still equal to 1. So we have dy dx equal 1. So dy equal dx. Now, after that, we have to first do. Now, one thing you notice here is that, they said from, I'm solving B now. They said from 0, 1 to 1, 1. So you can see that x, y, x, y. So you can see that y does not change here, right? Y still remain 1. So change in y will be what? Will be 0 like that, because it doesn't change, right? Change the y will be like y final minus y initial, right? So y final is 1, y initial is 1, so that will be 0. So dy dx is 0. So in your integral, this is what you should keep in mind. Your integral, it should be, now let's call that I1, because we want to do two integrals here. We first do the integral from this point to this point, and then from this to this. So your I1, okay, will be the integral from, so the only thing that is changing is x from 0 to 1. So we have to do 0 and 1, and we have to express everything in front of x. So if you want to do that, remember our integral is what? From x squared minus y dx plus y squared plus x dy. So we already see that dy is equal to 0. Is that not? So I1 will be integral from 0 to 1. Now, we have x squared minus, so y is a constant, it doesn't change, so, and it is 1. So you have to replace y with 1 in that case, okay? Not with x plus 1 again, because y is not x plus 1. So now we have dx plus, so y squared will be 1 squared plus x dy. So this is how you approach questions like this. Whenever you see that you are given 2 points, and maybe like y is not changing, then in that case, it's a constant. So dy will be 0, and then of course, sorry, I made a mistake. I was not meant to delete everything. Yeah, I've deleted some part of the question we are solving next. So that's how you solve the question. It's very easy now. So I1 equal integral from 0 to 1 x squared minus 1 dx plus x plus 1 dy, or you say 1 plus x, which is the same. Okay, now, okay, sorry, we said the y is now 0. Okay, so if you put 0 here, everything else has gone. So you just have I equal integral from 0 to 1 x squared minus 1 dx. Everything here has gone. And then you integrate. What would you have? So if you integrate this, you have x cubed divided by 3. I don't need to teach you that one again. Then minus integral of this will give you x. Okay, is that not minus 1 x to the power of 0 is still minus 1. So that will be minus 1, x1 plus, okay, 0 plus 1, 0 plus 1. That will be minus x, right? So that is what you will get from 0 to 1. What would that give you? 1 over 3, 1 cubed over 3 minus 1. That's for the upper limit, minus 0 cubed over 3 minus 0. So everything here will be 0. So the answer will just be 1 over 3 minus 1, which is 1 over 3 minus 1 is 3 over 3. And that will be 1 minus 3, which is minus 2 over 3. So that's for the I1. Don't forget, let me write it somewhere here. I1 equal minus 2 over 3. Now let's do for I2, okay, because I'm going to take this off. So we have to solve for I2 as well, which is from the second 2 points. So for the second 2 points, if you take them, it is from 1, 1 to 1, 2. So if you want to solve that, how would you do? So from 1, 1 to 1, 2. So that will be your I2, and that will be integral from. Now if you check, this is x, y, x, y. So x does not change in this case. Can you see? So the x is going to be what? It's going to be 0. So and then it's only y that's changing from 1 to 2. From 1 to 2. So your integral will be from 1 to 2, and everything will be in form of y. So that will be dy. So now normally your integral is what? Your integral is x squared minus y dx plus y squared plus x dy. Now it will be equal from 1 to 2. So dx is already 0. So you don't even need to put anything here because it will be 0. And then now, because x is constant, that's why changing x equals 0. So an x is constant, x is 1. So it will be 1 squared minus y. Now times 0 because dx is 0. Then plus, so we now have y squared plus x is 1 dy. So everything here has gone. So we have what? We have I squared. Don't forget the integral covers these two functions. So we have y squared from 1 to 2 plus 1 dy. So we have to integrate this with respect to y. So that will be what? So here it will be what? It will be, if you integrate y squared, that will be y cubed divided by 3 plus y from 0 to 2. So you can have 2 cubed divided by 3 plus 2. When you put the upper limit, then everything minus, when you put the lower limit, this is what you have. So everything is 0. So you have 8 over 3 plus 2, which is 8 over 3. 2 can be expressed as 6 divided by 3. So I'm just trying to make the denominator the same. So you have 8 plus 6, and that's 14 divided by 3. I hope I'm correct. Oh, I've made a mistake. It's from 2 to 1. It's from 2 to 1. Don't forget 2 to 1, or 1 to 2 rather. So this should be 1 cubed over 3 plus 1. So I've made a mistake. Anyway, nothing spoils because it means that everything here is now what? It means everything here is what? Is 14 over 13. So that's what I will just have to change. So 14 over 13. Sorry, 14 over 3. Then minus everything here, which will be 1 over 3 plus 1. Plus 1 is what? 3 divided by 3. So 14 over 3 minus, this one will be 4 over 3. And that will be 10 over 3. So that's your I2. So that's your I2. So don't forget, I1 was what? I1 was minus 2 over 3. Now I2 is 10 over 3. So this is what? So, and don't forget our property of line integral. There is one we wrote here, of course, you can see. So that I think is linearity. No, it's not linearity. I think yeah, is this breaking the parts. So you are going from, like, you can break this part C into 2. So you add them together, like something like this. Remember, so just like this. Our question initially stated that we are going from where? We are going from 0, 1 to 1, 2. Now we split it from 0, 1 from the beginning to 1, 2 eventually, which is the end. But we first go to 1, 1. which was like the AM, BM that we wrote. I hope you understand. So it's like going for A1, B1. Okay, then you continue from AM, BM to what? A to B2. That's just it. So you cannot add them together. So your I now, okay, the original I, the full part will just be I1 plus I2. I hope that's clear. So that's what you will do. It will be I equal I1 plus I2, and I will be equal to minus 2 over 3, that's I1 plus 10 over 3. Of course, that will be minus 2 plus 10 over 3, which will be 8 over 3. That's all. Now for the last question, which is about the parabola. Okay. So for the parabola, we have been given it has been parametrized. Yeah, let me use that word. So because if you remember in this question, in that beginning, I told you that if it is parameterized, you have been given your x and y. You already have this function, right? You're not giving your x and y in form of another same function t. Then you have to find t. Don't worry, you will see here. You will see it here. Let's proceed. So what we want to do here is that for this parabola now, normally our equation is what? Our integral is x squared minus y, right, dx, okay, plus y squared plus x dy. Now we've been given that x is t. Are you following? We've been given that what? X is t and y equal t squared plus 1. So we have to find out these. So we have been given x as a function of t and y also as a function of t. So that means that we have to find dx dt, which will be equal to 1. So in that case, dx equal what? dt, if you cross multiply. And from here, you have y equal 2t. Sorry, dy dt equal to t. Is that not 2t? So dy will be equal to what? 2t dt. I hope you understand. So that's what we want to do. So we now replace the dy and dx as a function of, as in terms of dt. Yeah, that's what I want to say. So we replace them in terms of dt. So how would you do that if you want to replace them? Then you have to substitute x and y in form of t as well. You get what I'm trying to say now. So I will be equal to, okay. So and if you are choosing your constraints, so in that case your t will be equal to 0 to t equal 1. In case you are parameter, it is parameterized. So it will be from t is equal what? 0 to t equal 1. So that is how you set your limit for that t in that case. So from 0 to 1. Now, so what are we going to do? We're going to have integral of, so from 0 to 1. So x is what? X is already t squared minus, right? Y is what? Y is t squared plus 1. So what I've just done here is that I change x to t because x is t. I'm just changing this integral now. I'm rewriting it in form of t. So t squared minus y. Y is what? T squared plus 1. Then everything. Now you now change your dx to what? dt. Plus y squared. What is your y? Y is t squared, abi, plus 1. That squared. I hope you understand. We had y squared here. Now y is t squared plus 1, so we square it. Plus what is x? X is t. Then dy is what? Dy is 2t dt. This is what you have to evaluate. If you do it correctly, it will be I equal integral from 0 to 1 t squared minus t squared plus 1 dt. So this is even clear that t squared will cancel t squared. But let's be patient. We're going to do that. So let's complete this line. So we have plus, if you evaluate this one, you will get t to the power of 4 plus 2t squared plus 1, then plus t. Don't forget everything here, multiply by 2t dt. Okay, so of course this has cancelled. Now one thing you should notice that I've made another mistake here. It's supposed to be minus opening this bracket, so it will be minus t squared minus 1. So after this square cancel minus t squared, your integral remains from 0 to 1 minus 1 dt. right? Minus 1 in that bracket, then dt. Then plus, if you open this bracket, you have 2t to the power of 5, right? Minus 4, sorry, plus 4t to the power of 3 plus 2t, right? Plus, if you use this to multiply to multiply this, you have 2t squared, right? So you have that. So when you have that, then you have dt. So you now have I equal integral from 0 to 1 minus dt over here plus 2t to the power of 5 plus 4t to the power of 3 plus 2t to the power of 2 plus 2t dt. I hope this is clear now. Then we can now continue our evaluation till we get our final answer. So we now have I equal integral from 0 to 1 minus 1. So you cannot factorize, everything here is like, this is 5, okay? So everything here is like, you are trying to, this is everything here like this, dt, don't forget. So you can now say minus 1 dt. So, if you open the bracket with dt here, or you can simply just say factorize dt in both expression. You consider this as a single expression, consider this as a single expression. So what would you have? You just have minus 1 for this term plus every other thing in that bracket, minus 1 plus 2t to the power of 5 plus 4t to the power of 3 plus 2t squared plus 2t, then everything dt. I hope that's clear. So after you do this, okay, you can now integrate now. So I equal integral of from, okay, if you integrate, you don't have to add integral again. Integration of minus 1 will give minus t because you are integrating with respect to dt. So plus this one will give 2t6 over 6 plus 4t to the power of 4 over 4, right? I think 4 will cancel 4 now. Then plus 2t to the power of 3 over 3, then plus 2t squared over 2, all from 0 to 1. So, and if you evaluate this, your answer will be 2. I don't have to do everything. So that is how you do it if you are given for parabola where the x and y are given in parametric form. Now, the last question I'll be solving here is also similar to the one we've solved here. So if you are given this, so what you have to do, of course, is like what we have been doing before. Okay, so you just have to, from here, y is equal what? Y equal 4x squared. That solution. So dy dx, of course, will be 8x, right? So for that reason, dy will be what? Dy is not dx in this case. It is 8x dx. And then you go back to your integral, right, of x squared plus 2y dx plus xy dy. So you want to replace so now, of course, it is from a 0, 0 to 1, 4. So in this question now, you can see that you are expressing it in form of dx, in form of x. So I mean, it will be x squared plus 2. Y is what? Y is 4x squared. So everything dx plus x. Y is what? 4x squared again. Then now dy is what? 8x dx. Now, because it's in dx or in form of x, so it should be from 0 to 1. X, y, x, y. 1 for the final, 0 for the beginning. I'm talking about x. So that I would be what? I would be from 0 to 1. So x squared plus 8x squared dx plus, now you have to multiply everything together. When you multiply everything, you have If you multiply this, that will be 4x cubed. Multiply by 8x, 4 times 8, that's 32 x to the power of 4, then dx. Okay, so now I is equal integral from 0 to 1. So x squared plus 8x squared, that's 9x squared, right? 9x squared dx plus 32x to the power of 4 dx. Now let's factorize. So that will be 9x squared plus 32x to the power of 4, everything dx, right? Dx is common if you understand it that way. So then you can now integrate, okay? So you don't have to add integral again when you are integrating already. So that would be 9x cubed divided by 3 plus 32x to the power of 5 divided by 5 from 0 to 1. So this should be 3x cubed plus 32 over 5x to the power of 5 from 0 to 1. So if you evaluate this, you should have, if you put 1, that would be 3, 1 cubed plus 32 divided by 5, 1 to the power of 5. Then if you put 0, everything will be 0, right? So everything will be 0. So everything will go. Then you're left with 3 plus 32 over 5. In terms of 5, 3 will be what? 15 divided by 5. That's 3 plus 32 divided by 5. So your answer will be 15 plus 32 divided by 5. And then your answer would be 47 divided by 5. So if you find it, it will be 9.4. So that's the final answer. So for now, this is where I'll be stopping for line integral. So in another video, I'll be uploading for vector line integral. So thanks for watching. If you enjoyed this video, please ensure you like it and then share with your colleagues that are also struggling with line integral, and subscribe to my YouTube channel for more video tutorial, and ensure you click the notification bell so after you subscribe, so that whenever I release the next video, which is the vector line integral, you'll be the first person to get the notification. Thanks for watching.